of 5 centimeters on the x-axis, and then a charge of 9 microcoulombs at a position of 315 centimeters on the x-axis. We want to know what's the force in newtons on the 4 microcoulomb charge due to the 9 microcoulomb charge. So if we would sketch out where they're located, 4 microcoulombs at 5 centimeters, 9 microcoulombs at 315 centimeters. We'll be using Coulomb's law, of course. So first looking at just in symbols, there's a constant K that's always 9 times 10 to the 9th in standard metric units. Charge 1, charge 2, both in coulombs, and r squared, the distance between the centers of the two charges. And we're just using point objects here, so the distance between the two objects, this needs to be in meters. So first calculating r, one object's at 315 centimeters, the other at 5 centimeters, so there's 310 centimeters between them. More importantly, we need to change that to meters. 310 centimeters changed to 3.1 meters. So you should put this into your calculator, press pause in the video, and do this calculation. 9 times 10 to the 9th multiplied by 4 times 10 to the minus 6, multiplied by 9 times 10 to the minus 6, divide by 3.1 squared. Welcome back, and here's the answer I came up with. Magnitude of 0.0337 newtons. In scientific notation, 3.37 times 10 to the minus 2. Now the direction. We're interested in the 4 microcoulomb charge. It's positive. The 9 microcoulombs positive. It's going to be repelling between those two. So the force is to the left. I'll put a minus sign on there, taking the traditional view that to the right on the x-axis is the positive direction. So the vector force would be minus 3.37 times 10 to the minus 2 newtons. Part B, calculate the force on the 9 microcoulomb charge due to the 4 microcoulomb charge. Give this a little thought. You might be tempted to just jump in and, well, we've got the constant, we've got the first charge, 9 times 10 to the minus 6, 4 times 10 to the minus 6, distance between them, 3.1 meters. Does this calculation look familiar? Yes, just the order of the multiplication is back and forth, but that does not make any difference. 4 times 3 is 12, 3 times 4 is 12. So the exchange of the charge numbers here does not change the result. We get the same magnitude for the charge, for the force on the 9 microcoulomb charge as the force on the 4 microcoulomb charge. The only difference is direction. The vector force on the 9 microcoulomb charge is plus 3.37 times 10 to the minus 2 newtons. It's kind of an example of Newton's third law. The force on these two objects, the force on object 1 and object 2, same magnitude, opposite direction. So I hope that was instructive. Keep practicing.